Assalamu alaikum wa rahmatullah. Welcome everyone. Today we are going to discuss about nuclear fission and nuclear fusion, which is the 25th chapter of IGCSE physics Edexcel. So let's discuss what is fission and fusion. In short, we can say that nuclear fission means when the heavy atoms split into lighter atoms and other pieces, then that is known as the nuclear fission. And nuclear fusion refers to the lighter atoms which is forced to join together to make a heavier atoms. Usually in the both of these process, what happens is that the mass of the starting atoms or the mass of the reactant is greater than the mass of the product, and the missing mass is usually converted into the energy. So let's discuss in detail what is nuclear fission. So as we already discussed, that nuclear fission is a splitting of a large atomic nucleus into smaller nuclei. In the process of nuclear fission, what happens is that a slow-moving neutron hits uranium-235, which converts into uranium-236. This uranium-236 later on splits into two daughter nuclei, which is barium and krypton. At the same time, 3 additional neutron is also produced, and as well as gamma radiation emits. So what happens is that in a nuclear fission reaction, a slow-moving neutron is absorbed by the nucleus of uranium-235, and in the nuclear reactor, a neutron is absorbed into a nucleus. So this caused the nucleus to become a uranium-236, which is violently unstable, and the entire nucleus split into 2 large fragments called daughter nuclei. The resulting nucleus of uranium-236 is unstable and splits apart, and the fragments of this decay are 2 daughter nuclei, which is barium-144 and krypton-89. The decay also produces a gamma radiation and 3 more neutrons. So the equation can be used as it is over here. So what we can see is that the additional 2 daughter products, which is a barium and krypton, 2 or 3 neutrons are also exploded out of the fission reaction that we have already discussed, and these can collide with other uranium nuclei to cause further fission reaction. Now usually this process is known as a chain reaction. In the process of chain reaction, the reaction takes place without a control, and due to these slow moving neutrons later on hit other uranium-235, so this process takes place like a chain reaction, like a chain. So that's why it's called a chain reaction. So we have already discussed what is a nuclear fission and fusion. So usually in the power station, we want this chain reaction to produce a lot of energy, but at the same time the reactions need to be controlled. So how can we achieve this? Before moving further, we need to know the certain terminologies, which is nuclear, what is a fissile material, and what is a critical mass. Usually fissile material is a material which is capable of sustaining a nuclear fission chain reaction, and by definition fissile material can sustain a chain reaction with the neutrons of thermal energy, and uranium-235 is called a fissile material because it can go through the process of splitting. Okay, now what is a critical mass? A critical mass is the smallest amount of fissile material which is necessary for a sustained nuclear chain reaction. The critical mass of fissionable material depends upon the nuclear properties. So this is very important that we know what is a critical mass and what is a fissile material, because when we are doing the nuclear fission reaction, the material that we are using, which is uranium-235, must be able to sustain a nuclear fission chain reaction. At the same time, there must be a minimum amount of uranium-235 for a nuclear chain reaction to take place. Now regarding atomic bomb, if we think about how does an atomic bomb produce, then we can come to this conclusion that in an atomic bomb, what happens is that two pieces of fissile materials, they're small, which is smaller than the critical mass, they're forced together under the high pressure to form a mass greater than the critical mass. The result is a chain reaction with the rapid and uncontrollable release of huge amounts of energy. So this is what an atomic bomb can create, and an atomic bomb, we know that how much destruction that it can cause. Okay. nuclear reactor, which is the another important part of the chapter. So usually nuclear fission releases a lot of energy as a kinetic energy with the fission products, and the thermal energy from the nuclear chain reaction is used in the nuclear power plants, power stations, to heat the water to produce the steam. This steam later on drives a turbine to generate electricity. Those who have studied the unit for energy, we already know that like the other renewable and non-renewable energy, they can also drive the turbine by using the heat energy, which later on is used to produce the steam. The water is given the heat, and that from that water we are getting the steam, and that steam is helping to drive the turbine to generate the electricity. So usually inside a reactor, this is an important part, a nuclear reactor, which you will find in your book, the figure of a nuclear reactor. Now within the nuclear reactor there are certain components. There is a fuel rod, there's a fuel rod, there's a moderator, there are control rods, there's a shielding, and there is a coolant, and which is used for cooling the process. So if you find this figure in your book, we will go through each of this part, which is what is the control rod, what is the function of graphite core or the moderator, what is the function of control rods and the concrete chamber. Overall process, we need to know how the overall process takes place. So inside the fuel rod, what happens is that the nuclear core contains the fuel rods of enriched uranium, and this enriched uranium is uranium-238 with a very high proportion of uranium-235 that is found in the natural reserves of the uranium. The rods can easily be inserted and removed to load and unload the reactor. So usually each rod is used for a few months until the amount of uranium-235 is greatly reduced. Now what is the function of the moderator? Usually the moderators are placed in the gaps between the fuel rods and the control rod, and it is filled with the graphite. The main function of a moderator is to absorb the kinetic energy of the neutrons to slow them down. This is because the slow neutrons are more easily absorbed by the uranium-235, and the neutrons slowed in this way can start the fission process. Without it, the neutrons will be going too fast and will escape from the reactor without creating the fission. So moderator has a very important function in a nuclear reactor. Control rods are made of the metals such as the cadmium or boron, and these absorbs the neutron and make them out of the fission process completely. If the rods are fully inserted, the chain reaction is almost completely stopped and the rate of production of heat is low. So if the rods are moved out, the reaction starts going faster and faster. So control rods have a very important function as well. Now shielding is another important part of the nuclear reactor. Usually there is a high energy of the neutrons and the gamma ray released during the process of the fission, we already know that the gamma rays are very much highly penetrating ionizing radiation. Now what does the shielding does is shielding has to be used to absorb this ionizing radiation. The reactor vessel is made of steel and surrounded by a concrete layer of a few meters of thickness. This prevents any radiation to escape, even the neutrons. Now cooling is also necessary for the nuclear reaction, within the nuclear reactor, to make the nuclear reactor. There are certain coolants which is used. Before that, we know that what is the cooling. Cooling is also needed to prevent the reactor overheating. This is done by circulating the pressurized water of another fluid through the reactor. In a power station, the exhaust from the reactor is used to boil further water for turbines. Usually the carbon dioxide is pumped around the reactor to transfer the energy to the water in the heat exchanger. The water turns to steam, which turns a turbine, and in this way which turns a generator and generates the electricity. So overall, these are the functions and applications of different part of a nuclear reactor. I hope this part is clear to you. Thank you very much. We just have a demo class to discuss about the basics of nuclear fission, and later on in the next class we will talk about a nuclear fusion reaction. This is Akumullahu Khairan. Thank you very much.